Welcome back to Low Stress Math with Mrs. Bono. We are reviewing for the final, and this is review number 3, chapters 4 to 6, functions and systems of equations. Now, we did the first part, so this is part 2, and we are starting on page 10. All right, let's take a look at this equation. So, here's the equation of the graph. Well, the graph of an equation. We don't know what the equation is first. And before I do this, I'm going to grab my highlighter and I'm going to highlight the y-axis, because the two things that you need in order to write the graph of the two things that you need in order to write the equation of a graph is the y-intercept and the slope. So the y-intercept, B, so I'll just put a circle and a line so it looks like a B. B is where my line intersects the y-axis. And this is the y-axis, the vertical axis. So it's right here at 0, 3. Now, the other definition for the y-intercept is the y value when x equals 0. So the y value is 3 when x is 0. So B equals 3. So that's my y-intercept. Now I have to find the slope, m. M is going to be rise over run. That's the slope. Now it doesn't matter which 2 points you pick. So I'm just going to start here at the bottom, and I'm going to count boxes or sides of boxes. And I think of it as like streets, and wherever the grid crosses, that's like a street corner. So if I was giving someone directions, I'd say, all right, go up 3 blocks and turn left and go 1. It's kind of like that to find slope. I'm going to go up 1, 2, 3. So my rise is 3. And then to get to the point, I'm going to run. But that run is left. I had to make a left turn. And as you know, negative numbers are to the left of 0. So if I'm going left, it's negative. And I'm going one spot, 1, negative 1. So my rise is 3 blocks, 3, and my run is negative 1. So rise, 3, run, negative 1. And if I reduce that, I get negative 3 for my slope. So that's the m. Y equals mx plus b. And I'm going to replace the m with negative 3 and the b with positive 3. And I end up with the equation y equals negative 3x plus 3. Y equals mx plus b, y equals negative 3 for m, and positive 3 for b. All right, down here. Tell whether each table represents a linear or nonlinear function. Explain your answer. If it is linear, write a linear function or an equation. Okay, in order to be a linear equation, it has to have a slope, a constant rate of change. Rate of change is the difference between the numbers. It has to stay the same or be equal fractions. So, in order to do this, we're going to have to find the change in x and the change in y. And so the slope is the change in y over the change in x. And how do I find the change in y and the change in x? Well, simple enough. Let's do, how do I get from 28 to 26? Well, I have to minus 2. How do I get from 26 to 22? Ooh, I have to minus 4. From 22 to 14, I'm going to minus 8. Okay, so my changes in y are negative 2, negative 4, and negative 8. And now I'm going to go back up and I'm going to look at the changes in y, the changes in x. So to get from negative 5 to negative 3, well, that would be add 2. From negative 3 to negative 1, that's also add 2. From negative 1 to positive 1, that's also add 2. So now I have the fractions, negative 2 over 2, 4 over 2, and 8 over 2. Oh my, those are not equal. They're not. These are not equal. And if they're not equal, then that is definitely not linear. But it's still a function. How do I know it's a function? Negative 5, negative 3, negative 1, positive 1. The x values are not the same. If the x values are not the same, then it is a function. The x values do not repeat. The x values are, this makes it a function. So this is definitely a function, but it's not linear. So it's not linear because there's not a constant rate of change. And constant just means it stays the same. So it's not a constant rate of change, it's not staying the same. So now, let's take a look down here for some delta x and delta y, and I'm going to look for my slope, which is the change in y over the change in x, and we'll do the x values first this time. To get from 2 to 4, add 2. From 4 to 8, add 4. From 8 to 10, add 2. Not looking good, but not bad. We'll keep that. Then on the bottom, to get from 3 to 8, I add 5. To get from 8 to 18, ooh, I'm going to add 10. And to get from 18 to 23, back to adding 5. So I now have 5 over 2. And, oops, that's supposed to be a pink 2 on the bottom. Bono, bono, bono. You start off all nice and color coordinated, then you muck it up. Here we go. And let's see, the next one is going to be 10 over 4. Well, you know, 5 times 2 is 10, and 2 times 2 is 4. I think these are equal. So far, I have a constant rate of change. Even though the numbers are not the same, they're still equal to each other. Those are equal fractions. And I can reduce 10 over 4 to 5 over 2. So that is a constant rate of change. The slope did not change. It's just a multiple of the original. So that's fine. And the last one is going to be 5 over 2 again. And we already know that that is equal. So this does have a constant change. So ding, ding, ding. This is a linear function. It has a constant rate of change. In other words, these are all equal. Now that's my slope, that's my m. In order to finish this off though, I do need a b. Ugh, I have to work backwards again. So I'm going to find my b by being backwards. And let's take a look at that. So 10, 8, 4, 2, I'm going backwards. This would be 0, I'm going to subtract 2. And then I'm going to subtract 5 to get negative 2. So now I have 0 and negative 2. My b is negative 2. b equals negative 2. m equals 5 over 2. My equation is going to be y equals 5 over 2x minus 2. There we go. Not horrible at all. Okay, graph the following system of equations. Well, the first one is easy enough. I know my m is 3 over 1, so I'm going to rise 3 and run 1. And my b, I'm going to begin at -6. Begin at -6. So all the way down here at -6. Oh, you can't see what I'm doing. Look at me being all foolish. All the way down at the bottom at -6. And I'm going to rise 3, 1, 2, 3, and run to the right 1. Rise 3, 1, 2, 3, run 1. Rise 3, run 1. All the way across. So there is my first line. I like that line because I didn't have to do any work and I didn't want to do any work. Yay. Now this one, oh dear, there's a lot of work involved. I'm going to have to write that over here. 2x plus y equals 4. I'm going to have to subtract 2x from both sides of the equal sign because my goal is to get the y by itself. Y equals -2x plus 4. Begin at the back at the b, so I'm going to have b equals 4, and to get more points, I'm going to need -2 over 1. So I'm going to rise 2, and I'm going to go left 1. So starting here at 4, begin at 4, and rise 2, left 1. Oh, patoop, it only gave me 2 points. But I can follow the same pattern, and I can drop 2 and go right 1. Because the opposite of rise is to go down or drop. The opposite of left is right. Those are equal. So now I'm going to go down 2, right 1. I see where it's going to cross already. That's good. And it's going to cross at 0, +2. I'm not going, oh, sorry, I lied. The x value goes first. 2, 0. 2 to the right, it doesn't go up and down. So there's my solution at 2, 0. Yay! Oh, what did I do with my graph? I made a mistake. I have to write the equations on the graph. So this one's going to be y equals 3x minus 6. And I have to use the original equation on the other line, which is 2x plus y equals 4. So you have to go back and use original equations when you're labeling your graph. But my answer, 2, 0. Or sometimes they want you to write it like this. X equals 2, y equals 0. It's the same thing. My preference is to write it as a ordered pair, but close enough for government way. All right, now we're going to find solutions to systems. And this one says use substitution. What does that mean? That means that this is y equals x plus 1. So where there's a y, I'm going to substitute x minus 1. So I'm keeping the 2x minus 3. I'll fix that in a minute. But where the y was, that's where I'm going to substitute, in parentheses, x minus 1. And I still have equals -1 on the other side. Now, with all this subtraction, I'm not happy. Not happy. Change my my minus to a plus, and my second number to negative. Change minus to a plus, change the second number to negative. Because adding a negative is the same as subtraction, and it does make it a lot easier. So, 2x plus -3 times x, -3x, plus -3 times -1 is +3 equals -1. All right, 2 minus 3x is -1x, plus 3 equals -1, minus 3 from both sides, and -1x, because this is 0 now, is equal to -4. Divide by -1, divide by -1, and you get x equals +4. And that's only half the answer. You got to go back, you got to fill in 4 in the other problem to find y. Y equals x minus 1. Y equals 4 minus 1. Y equals 3. Now I know my answer. X is 4, y is 3. I can write it as an ordered pair 4, 3. But you know that if you got that going on, you got to check it. So I'm going to use the second problem to check it and make sure that it's equal. So 2x minus 3y equals negative 1, 2, and where the x was, I'm going to put 4, minus 3, where the y was, I'm going to put 3, equals negative 1. 2 times 4 is 8. 3 times 3 is 9. 8 minus 9, negative 1 equals negative 1. Yay, it checked. So now I know that 4, 3 worked in this equation and in the second equation. Solve the following system using elimination. I like elimination. Now looking at this, in order to eliminate something, you have to have the same variable, the same coefficient, and opposite signs. So for this particular problem, I'm going to be eliminating the x value. Why? Because I have the same coefficient and opposite signs. So if I add these two together, 2y plus 2x equals 10, and 4y minus 2x equals 14. If I add them together, that is going to be 0. 2y plus 4x is 6y. That's 0 equals 10 plus 14, 24. Yay! Divide both sides by 6, and y equals 4. Okay, y equals 4. Be careful. Make sure when you go back and you do the top equation, 2y plus 2x equals 10, you substitute for the y. 2 times 4 plus 2x equals 10. 2 times 4 is 8, plus 2x equals 10, minus 8 from both sides. You get 2x equals 2. Divide by 2, and x equals 1. So now I have my solution. The solution to this system is 1, 4. Make sure you put them in the right order. X, Y, X, Y. Now I have to check it in the second equation to make sure I did it right. 4y minus 2x equals 14. 4, remember, y first, times 4. Helps if you finish things off with them parentheses there, Bono. Minus 2 times 1 equals 14. Let's see, 4 times 4 is 16, minus 2 times 1 is 2, equals 14. 16 minus 2, 14 equals 14, and that checks. So that's the two of the three methods we used for solving systems of equations. Okay, have a great day, and I will talk to you soon. Bye.